So, following off of what I did yesterday, I think it's time to dive back into my object file PE COFF stuff. So, I'm going to start by just reading through OBJ from raw and then digging into the organization and, catching up on the to-do list and stuff and the organization of the binary files. There's a little bit of ELF stuff here. I want to think about maybe splitting off the reusable headers and simplifying those down, and then having the more heavyweight generator library, and then having the utilities. So, my goal, my thought, is this is all going to be just a lot of tedious stuff. It's one of the reasons I can't do 24/7 directly on the object file stuff is it's just tedious and slow. It doesn't have that excitement factor that an RPG simulator does. But I'm feeling like I'm in a good mood, good enough mood to sit and work on this. And no surprise, it's been about a year since I did it, and I often find projects like this happen in a cycle where you work on it for a while and you take a break, and some kind of pattern starts emerging of when you're able to make more progress on the same idea. So, been almost a year since the last time I started up working on this. We're just going to take a clean slate looking at this. Last year, the progress I made was I built up all of the basic format stuff that I need for generating PE files, which are the executables on Windows, COFF files, which are the object files on Windows. I touched a little bit the ELF format as well, which are the object files and executables on Linux, but that's not as far along. We're going to start again with just PE COFF stuff. We're not going to be trying to develop out the Linux side yet, but this time we're going to go through with an eye to, after all this time, I know a little bit more about the different layers of this that I want. I've got sort of pure formats, type def spec stuff. I've got, a library for generating PE files and COFF files. And then I've got little utilities, and I kind of want to formalize those splits, because the PE stuff should probably, like the format stuff should be very reusable. Library stuff should be more carefully vetted, and the utility stuff should get all that production stuff like help menus and stuff, and so having it organized out will just help me keep track of my to-do list and what kind of tasks exist in which parts of the program, or code base I should say. So for starters, I have this utility over here called obj from raw main. It's currently directly tied into the PE version. I think what I want to do is shift it from being called obj from raw to just having a PE specific name, like I do with table and the rest of these. So if we take a look, gen.main is a little bit different. This is like the test bed for the generator library. Parse.c is different. This is like a helper layer for specific sort of one-off parsers, like the self-image system, which supports the symbol sets. And then there's table, which is this thing. It just dumps out all the sections right now. And there's probably upgrades I want to do to that, but I also have them all specifically being PE typed, and this one's also PE typed, so I'm thinking we maybe rename this to like pe.obj from raw, or like pe.raw or something like that, or just pe.datapack or pe.data, I don't know. Maybe it's still obj from raw, but I just want to PE type it directly, right? And there is no other thing, it's all over there. So it's just going to be, actually, I'm probably going to close forecoder and just do a round of renaming and organizing first, now that I've talked it out. So let's pull up some music, just chill out. We're going to kind of take this easy, ticking along at to-do lists. No idea how far we'll get. Oh, file pilot, please tell me you don't have the issue where it's impossible to find empty space. Create a new file. I can come down here and go new, right? Oh, because you think I've selected something. Please, please. This is like... Do I have to just memorize a shortcut? Is that the trick? No? Control N is a new window. New folder. Okay, so now when I do this, does that... No, it's still gone. I don't see any way to... Okay, what about if I go into the command lister? I forget how you do that in this one. Open new tab, close inspector. Like F1. Commands, Control Shift P. New folder. Create folder, Control Shift N. There we go. Okay. Alright, I'm just gonna keep track of notes that I have. You know, I use Red Debug, I use File Pilot. I might as well start keeping track of notes that I have on how these things work while I'm working. Test to the people who make them. Alright, binary. I don't really use underscore or dashes usually, so I'll go with underscores. Weird, maybe this has been left running for... Yeah, that definitely looks like it was affecting... Feels better because it's animating. It feels funny when it's having frame rate issues, but it's okay when it's at full speed. And then we also want I'm gonna separate things out here. Just a to-do list. I'll leave it here. I'm gonna say this can actually live up here. Now at least. Now, what do I want to do with these parse files? These are the ones that support self-image. They implement one-off quick parsers. Hmm. Stop it. What's the point? All right. Oops, let's just start off by okay, so what about, I mean, surely I've got like, okay, build fly. What does the script look like? Like this has, oh, we got rid of bin dash everywhere. Somehow one got the test load gen dot test load gen. Okay, that's a real thing. So these are targets for the binary utilities to test themselves on. These just don't count. Util e bj from raw dot c. Oops, we got a four-coder crash. That's not very common. This now lives under self-image. Okay. Crash again. What is it? Oh, that's this is a good question. I might have put the title on this video in a way that's confusing. When I say PE COFF rewrite, I don't mean that I'm rewriting my PE COFF code. I mean that I'm working towards building a utility that rewrites a PE COFF file. So I want to make a utility that can parse in a file and then basically generate the same thing and then use that as a starting point to insert modifications. Right? So it's rewriting the object file. It's not a rewrite of the code I already have. Hopefully that clears up uh, the meaning. If you want an explanation of why I'm doing pcoff rewriting, I can go into more detail. But like it's some stuff we were working on yesterday, kind of just into this. So I'm building up the foundation right now. Okay, so what happens here? We're going to visit each of these symbols. Nice. I think this is fine. Okay. So Okay. Set this up. We don't want to be building the test program anymore. Test. Yeah. We want to be building table.c. We want to be running table. Hmm. There we go. Nice. So which of these are functions, which ones are not? Static and external. That's cool. These are the before main symbols, and that's why this is happening. Each each of these, section 4, special section that runs before main. Yep. You can see here we have, what is this, 20 pointers, 20 function pointers to execute the program. All right. Variable. Now, some are marked as static and some are marked as external. Are any of them external, but they are not resolved, though? I'm not sure. Not sure. Markup for 1-1. Yeah. Okay, so that's gonna make P table a little more useful. Check my Okay. I'm going to quick break here. Boom, let's get a little four-coder instance up for the 5-minute break sign. Zooming in. I think what I can do, let me just pull up BLD core here. I want to replace unit, source file, and options with file, source file, options, BLD link, sim. Build meta, build main. Right. It doesn't work. We still gotta come back and fix the way object file handling is gonna work someday. Yeah. Okay, so that kind of works. The symbol pack seems to at least be able to move the file from here to here, and we can compile or link to that one. Now, what are we gonna do here? I think we start with the generator. What it's about. And you grab one of these. Why do we name them all separately like that, I wonder? I don't know. It's not really a real AI API yet. What I say we do with this project is we're just going to proliferate tons and tons and tons of duplicate code for a long time. All right, real bad uh, code compression, and let there be duplications of our mistakes, let there be duplications of our bugs. The reason I'm saying we do this is despite the fact that I think that you don't want your code organized that way when it's at its best, there are just so many different ways that you want to fit this kind of knowledge into different places, right? There are places like self-image where you don't want a big expensive conversion. You don't want a parser that sort of extracts and indexes and spends some heavy compute to convert it to an abstracted format. You just want a real quick scan, get the thing you're looking for, and get out as fast as possible. It's sort of a one shot parse. Then there are times where we're going to be ingesting this file in order to rewrite it, which means we're going to want to completely understand it, shift its pieces around, and reconstitute them, make sure they all connect together correctly on the other side. And so it's essentially a deep parse and a deep reconstruction with modifications. Right? In order for that to work, it is going to need to do a deep parse with, reconstituting the data into easier to work with formats. So it can't be the same parser. So there are places where trying to deduplicate it, I think, would not honor the fact that they are very different contexts. And then there are places where not deduplicating it is saving you 2%. The context fit improvements like 2%, 5%, and just 10%, right? You could afford to lose a little bit of that context fit in exchange for massively decreasing the amount of lines of code, the maintenance burden. Problem is figuring out where to put the lines, what sacrifices to make, and what designs to pick. And the best way I can think to do that is to keep building tools that actually get jobs done. Let the duplication run out of control while we just get lots of these PE utilities that get jobs done. Then, at some point, we'll be able to do an audit over all of that. And when we do that, we'll learn what the real patterns are. We'll learn where we're overcomplicating things. So things like this might all be too much, right? This might be way more than we want. In all likelihood, what we want is an API that looks like this to begin with, right? Just begin generating and assume that all of this stuff is along for the ride. Now, why that's not already the case, I'm not entirely sure. So I don't want to just force into a refactor when I'm trying to use what I've already got to start a utility. Instead, I'm going to just embrace the duplication and get the utility up and running, and then I'll have more code. And this time, it's the first time I'm writing code that makes full contact with reality, as I'm actually doing it for a purpose motivated by a completely different project. Right? It's not just proof of concept work anymore. So that's how we're proceeding. Yeah, we're not doing any image related construction here. That is a point where I don't need to exactly duplicate what was happening. I think what we want to do is we're going to, well, let's start with not even this. How are we doing there? Still builds. Of course, now I have to assume this is a part of whatever I do here. I end up wanting it's just work. Oh. Yeah. I pe dot symbol pack exe. Run this target. We go over the RP. And then we want to do this here. Okay. Pack. Okay. So the kind of bug I'm running into here is my synth table. Interesting. So in order for this, in order for us to generate a header layout, it's saying there has to be a simple table set already. Okay. As long as that's failing build, then we know we haven't reconstructed. As long as that's haven't reconstructed the object file correctly. Okay, so next goal here is to go into gen main and start constructing section data. The way we're going to do this is going to match what we did over here. Up to this point. All right, I need to go see in the parse example how you pull out relocation. Okay. Got it. So to be just like this, except instead of saving them to an output stream, counting them pointer, I'm gonna just send them all into the table generator. Now label position. Things are starting to get a little nasty now. Because this wants to say, give me an offset from a block. This was with the idea that we were writing blocks first and then pointing symbols at them. Now so we have symbols that already exist and we know where they're supposed to point in their original blocks, but those blocks haven't been constructed yet. If we go and construct those blocks first, then we have to find a way to index to the block from where we're at here. We have to say, which block am I trying to label? On the other hand, if I do that first, then I'd have to go and get them. But the other issue is, where do those blocks come from? Those blocks are these things. Technically, they could exist first. And what we would have to do is get each block to exist and index them from section ID, and then to reference them here, and then reference them here to finish the section generation. The block would then be indexed by the record, which has a symbol, a section number, and an offset, which the record has as the values, right? That would get popped into the label there, the position label. Okay, so so it's another copy of this loop, except in the first one, I'm not going to do anything except figure out the block. Blocks I. Okay, so now the question is, can we go from symbol index back to a symbol? But this time I only want to run the allocation to get that far. Oh, we had this part finished already. Symbol table. Don't have any simple table baking happen. Why is that a part of the section stuff? I don't necessarily understand. I doubt that could possibly be everything. But that's progress. I thought the diffing worked better than this. What am I missing? The wrong, is it hex like image hex or something like that? Im hex? I felt like one of these was very useful for getting what I needed here. They agree on the first two. Then the timestamps are different. After that, right, pointer to symbol table looks different too. Here it is. Timestamps are number of symbols doesn't match. Interesting. They're all supposed to be just getting copied over. Where to symbol table? That just means the symbol table went somewhere different. That's not necessarily an issue. It doesn't know zeros in the object size. Okay, the virtual sizes. I think, as I'm looking at this, I think that the best course of action is going to be to build something with a slightly different approach than what I had in the original generator. The original generator worked as a nice proof of concept, and it got me to the point of being able to do OBJ from raw. This hex thing I'm using is called imhex. It's a pretty nice hex editor with like built-in patterns for common file formats and diffing and stuff like that. I am hex. All right. So after, let's see. So yeah, it looks like the first big issue here is that the that right there is the pointer to relocations. Hmm. Interesting. Why is there a pointer to relocations on one that has no relocation? That's another issue, probably. Okay, okay. So here's what I'm thinking. The generator was not a very robust approach. It was kind of a first pass. I think it's going to be a useful tool for looking at roughly how we want to structure things. You know, there's definitely be a lot of reuse of that code, and not all going to go to waste here. But I think we need a different architecture from the beginning. Switching over to Milton. So what I think we want, something that has the following structure. I want to be able to go. Here's an object file. Let's get very specific. We'll have ourselves a COFF object file. And we're going to want to be able to convert that into try to write a little. We want to have a COFF object file as the input. We're going to want the ability to convert from to kind of I don't know what I want to call this, like the COFF model. That. We're going to want the ability to do COFF model back to COFF object file. And then we're going to want, that's the ability to, this, we're going to want the guarantee that if you do gen after load, that's going to give you the same thing you put in, right? Now, we don't know exactly to what extent we want this to be true, right? Do we want that to be true to the byte level? That would be a great level of guarantee that it's identical, that it won't change anything, that it's doing the right thing. And if it was that precise, I'd be really happy. But if it wasn't quite that precise, it might turn out that there are reasons why being that precise overcomplicates other things, or there are other constraints that we are going to add to the table here. And it might be that that precision is such a heavy burden that dropping it in exchange for other payoffs is better for us. And so we might relax this idea to the point that while it might not be exactly the same object file, it should at least be the case that it's going to link in all of the same ways, right? It should be possible to generate programs with all the same behaviors, if nothing else. Right, so if that means that there are weird little enum codes here and there that get dropped because they seem irrelevant and can be done differently, or if the layout is slightly different, section object files packed and it doesn't, whatever, that's no big deal. But we'll need to be developing an idea of exactly we're going to want to be developing our sense of what that identity map is supposed to mean and how we're going to test it. Then the other thing we want to be able to do is we want to be able to take a COFF model COFF model edit it in place, right? So, points here that I want to make sure to highlight. Only for object files. Don't worry about object and in addition to all of these other things, that's one of the state. It should be possible to construct something like a blank object file. Maybe not from scratch, maybe from setup param X here, but it should be possible to make a COFF model that is essentially blank except for the necessary header flags and stuff. Start editing from there too, so you can do generator style stuff. Built Dynamics asks, what am I working on? So I am currently working on finding the best way to organize code that will give me the ability to rewrite my object file. So an object file, I'm not sure how familiar, what your familiarity with these systems is like. But when you compile your code, it creates object files before you link it, and so there's an opportunity to read and modify that data. And I'm taking advantage of that to build new structures that I can program with. And right now I've done fairly limited, like small little tricks on top of that, and we've still gotten tons and tons out of it. Just with the ability to read our own image as we're executing, we've been able to make some really huge inconvenience improvements over the C language without actually adding any new features. We don't need a new compiler or anything. There's other cool ideas that go a little further that require sort of reorganizing the data after it's been compiled. And we do have an object file generator that we've been using so we can pack stuff into the program. Like we can take shader code that is just sitting in a GLSL file, and we don't have to run it through we don't have to turn it into C code. We don't have to do anything with it except to say, hey, I want this text file to be linked into my program, and it generates an object file and the linker links it in. So the idea is to expand upon that, but our object file generator, we just did a little pass over it, seeing if we could parse an object file and then generate an object file from it. And the generator code we have is just, it's a little bit too first pass. You know, it worked well for generating simple raw blobs into an object file, but the next level up here is going to require a slightly more sophisticated and carefully designed model, and so I'm just sketching out what features I want. I'm thinking about making this data structure called a COFF model. I want these abilities. I want to be able to load the COFF model in from an object file. So I say, here's a raw object file. It parses the thing and builds a COFF model. I want another function that says, hey, given this COFF model, generate the data for an object file. And I want the rule that whenever I take an object file and do load and gen back to back, I should get something that's either exactly identical at the bit level or at least identical enough that it behaves the same way in every way that I care about. Not entirely sure yet what level of identicality we want, but something along those lines. Then we want the ability to edit the model in place in arbitrary ways. That'll, of course, how that works will depend on the data structure of the model itself. But we want to be able to make modifications, and that may entail having to design the COFF model to be somewhat higher level. We might have to add stuff, right? The COFF model, because it's not just going to be supporting this, but also these edits, it might be that this complicates the picture over what the object file has in order to make room for the editing. One example I have as an idea for this is when you have an object file that's baked down, the way you reference a symbol is with the symbol index. But if we're going to be modifying the set of symbols, maybe deleting some of them, maybe adding some, maybe rearranging them, we don't want those links to be in integers anymore. We want some kind of unique ID system where we can ID all of our symbols, reference them through those unique IDs, and then potentially shuffle, rearrange, and delete them. And then when we go to bake it out, it will render back down to the simple array of symbols and indexes into the array. That's just one little example of it. We kind of want that flexibility across the board, I think, in order to get farther. And then the final requirement that I added here is just that I'd like to be able to create one from scratch so that the same thing that I use for making rewrites could also still be used for generating. Right? I think with this basic structure set up, we should be able to serve both the purposes of being an object file generator and an object file rewriter from a single API. And COFF model might then become the ideal way to write high-level parsers to. You don't need a high-speed parser. If you need a high-level parser that maybe is slow but gives you lots of detailed information, then this structure here is the ambition to do it all in one. So I'm gonna do one last thing before I take a lunch break today. I'm gonna go and sketch out a replacement for all of this. All of this was our first pass, kind of cool, kind of showed there wasn't a whole lot of there in terms of our progress on the generator. Yeah, it's modifying object files or generating object files with. I mean, the idea first starts from generating object files from multiple sources, right, and linking them together so that you can create a compositional system, right? You can write assembly. This is very common practice when you have to write some handwritten assembly and mix it in with C code or C++ code, or if you have C and C++ code you need to mix. It could work in any language that's willing to work in the object file format. So my thinking is, what if we just get better at that? What if we get really good at creating, looking inside of, rearranging, and piecing together our programs at that level? Could we get a little bit more open compositionality between different language paradigms, different programming interfaces entirely? A little bit at a time, I'm pushing in direction object file intelligence in my code base and trying to and with the hope that someday all that object file intelligence will pay off in this big way, but in the short term also looking for immediate payoffs, what we're doing today. And just to close the loop on it, a big part of the idea is to do a little bit of like metaprogramming that's a post-process instead of a pre-process, right? Usually you think of metaprogramming as you examine your own code or you examine some kind of pre-code scripting model you have, and then you generate source code from that. The idea is, what if we run the compiler or look at what's in the object file and then do some post-processing so we can generate another object file with no new information, or strip some of the things out of that object file and generate a new one that replaces them with a denser or baked packing and different symbol resolution and stuff. So it's sort of post-process metaprogramming instead of pre-process metaprogramming. Okay, so the goal here is to sketch out the new interface that we're looking at here. COFF M, is that what we'll call it? Okay. That's goal one, is that that works. But then goal two is that we could do something like, what if I want to, I'm basically looking at, let's just do, hmm. Goal that I have in mind. The goal that I have in mind is to look at something section. And move all of that into a single section, like dot data section, right? If I were to take all of this data and say, I actually don't want there to be this section, I want this to be appended to dot data, what would need to happen? Well, to relocate data within the object file, I essentially need to say, first take the data block itself and append it to the data section. And then all the symbols pointing into this data block need to get relocated to the new data section. And then all of the relocations that were living in this original section need to get moved. Well, couldn't I just rename it to dot data? I think that just works. Like, it has to pay. Okay. Yeah, that actually just works. Because the linker just pastes that all together in the end. I think that's the way to do it. And then so the other thing you would want to do is you'd want to say, okay, this should have right, like we could go say somewhere there's got to be a symbol that will remember this. I think what we want is something like okay. I think it's a good time to go. I think it's time to go have a little break. I'll stop here. I'm gonna have my lunch. Come back maybe a few hours. Maybe I won't be back today because it is a little bit of a long first stream. But if I do come back, I'll probably be going back to the whiteboard and reading through the PE format stuff and just trying to come up with a full data model of all the things that I want to be able to include, right? And how they interconnect with each other. So I think that's the plan. Thanks for coming and hanging out. If you have today enjoyed it, then I would ask you to consider going to MrFort.com and becoming a supporter or a member. I'm counting on viewers who are seeing what I'm doing or who are following what I'm doing on Discord or on my email, my newsletter threads, to make the decision to help me keep going if you think what I'm doing is worthwhile. So consider that, and I will be back later to keep making progress. Later.